Welcome. We're working on lesson 2.7 today. The topic is derivatives of cosine x, sine x, e to the x, and natural log x. Oh, some of our favorite functions. And as you can see, the homework tonight is going to be a worksheet. All right, so this table will give you the answers to your probing questions of what is the derivative of these functions. So the derivative of sine is cosine. That's nice, huh? The derivative of cosine is negative sine. The derivative of e to the x is itself. It is e to the x. The derivative of natural log x is 1 over x. And so we know that that has a base of e. If that base changes, let's call it b, then that derivative becomes 1 over x, much like natural log x was, but there's a little correcting factor of natural log b going on. So we have natural log of b times x. All right, so what would I do with these? If you are a flashcard person, I would make some flashcards for these, you know. Make this the front side of your flashcard, and then make this the back side of the flashcard. Example 1, given the following functions, find f prime. So you can look up above because you have them. What is the derivative of sine? You are correct, it's cosine of x. Just look it up on your chart. B, what is the derivative of natural log of x? Well, according to the chart, it was 1 over x. And the derivative of cosine, well, we have this negative, don't we? And then the derivative of cosine is negative sine of x. So we end up with a negative negative. That's going to give me an f prime equals 1 over x plus sine of x. And C, well, you see these sum and differences? We did just cover that topic, didn't we? We know we can take each individual term and do its derivative. So the derivative of e to the x is itself, it's e to the x. Then I hit power rule, and the derivative of x squared would be 2x to the first, because I decreased by a power of 1. And that brought me from 2 down to a power of 1. And the derivative of a constant would be 0. So f prime of x equals e to the x minus 2x. Yeah, they start building. We start getting a lot of rules, don't we? For D, before I even begin, I'm going to rewrite this because this term can be rewritten as 1/3 natural log x, and that just makes it easier on our brain to see that it has a multiplier. It has a coefficient of 1/3. F of x. Derivative of 1 is 0. Derivative of sine is cosine, and then we already had the subtraction sign, so that stays. Plus derivative of natural log x, look up the formula for its derivative, and it's 1 over x. Now let's, oops, I didn't get a prime on that. F prime condensed down. I would say most math books would present it as 1 over 3x minus cosine x. Often if it's a lead, you know, with a negative, they'll just turn it into subtraction and put it as the second term. Especially since this last term was positive, doesn't it present a pretty picture here? Yeah, so often you'll see textbooks write it out that way. I think you will also see the AP do that quite often, rather than leading with that negative cosine x plus 1 over 3x. Not that it's wrong, it's just I would say most of the time they're going to format it like that. Okay, we come into letter E. We have seen these before. We cannot do derivatives of products, but we can do derivatives of polynomials. So let's FOIL this out and get what? A 6x squared, a plus 4x, a minus 21x, and a minus 14. Simplifying, pulling those two middle terms together, looks like a negative 17x minus 14. And now you're off to the races. Take your derivative, power rule all the way. First term will be at 12x, right? 2 times 6 reduce the power by 1. The next one, well, the derivative of x just turns into 1, so this is just going to be 17. And the derivative of 14 would be 0, the derivative of constant. So my final answer is going to be a 12x minus 17. Oh boy, F looks fantastic. That's what you were thinking, right? F for fantastic. Okay, let's erase this. And let's just restate some of this stuff. So I can make this an x to the negative 1 for the first term. Then I see it as a 1/2 x plus a 1/3 cosine of x minus e to the 4th. Interesting. This is a fantastic problem. F prime of x. The negative will come down, won't it? So I get negative 1. X to the, subtract a power, you get negative 2. X to the first, the 1 comes down, I get a 1/2, and x goes to a 0 power, so I don't need to write it down because that is 1. So I'd have 1/2 times 1, or 1/2. 1/3, the derivative of cosine is negative sine. Okay, I'm going to have to reorganize that baby, aren't I? And what's the derivative of e raised to the 4th? Well, since that is a number, it turns out to be 0. This is a constant, e to the 4th, right? It would turn out to be a number if you put it in your calculator. Therefore, its derivative is 0. Okay, let's straighten things out here, make them look nice. Could I put the 1/2 first since that's a positive? I think I will. And then I'm going to put this next term here, minus 1 over x squared. This really was 1/3 times negative sign, so that's going to be a minus 1/3 sine x. Or if you prefer, you could write it as sine x over 3. Doesn't that look pretty? G. Okay, just some straightforward rules is what I'm seeing when I look at G. The derivative of e to the x is itself, it's e to the x. The derivative of natural log is 1 over x. So I could leave my answer like that, or probably more likely I could have 4 over x minus 3e to the x. H looks horrific. F of x equals 3x to the 1/2. Remember those radicals? We most likely want to write them as exponential powers there. So I have 4/5 x to the negative 3 minus 2x to the negative 1/2. Power rule all the way. Just be careful with the math on it. So I'm going to get f prime of x equals, we're taking the derivative, so we take 1/2 times 3 gives me 3 over 2 x. 1/2 minus 1 gives me a negative 1/2. Next problem, negative 3 times negative 4 will give me positive 12/5 x reduced by a power gives me negative 4. Finally, I get negative 2 times positive, or negative 2 times negative half gives me positive 1 x to the negative 1/2 minus 1 would be 3/2. That was a tricky one. So much going on. Now let's just make it look nice. We'd have 3 over 2x to the 1/2 plus 12 over 5 x to the 4th, because of the negative exponent, plus 1 over x to the 3/2. Some wild numbers on that. And finally, let's look at our last one. I'm going to clear my screen. Okay, I've got 4x e to the natural log of 1 minus x to the negative 3. I like this one most of all. This one is confusing. But e raised to a natural log, remember how those kind of eliminate themselves? They create 1. So this really becomes 4x times 1 minus x to the negative 3, which I could really write as just a 4x minus x to the negative 3. Now let's take our derivative. f prime of x equals 4 negative times negative 3 x to the negative 3 minus 1 makes what? 4 plus 3 over x to the 4th. Very nice. A lot of problems on that front page, some difficult ones in that group. Okay, now we get pictures and a table. So example 2, the graphs of the functions f of x and g of x are given with the selected values in function, the selected values of the function h of x and its derivative h prime. Use the information above to find the following rules. So I'm just kind of taking my eyes, and you probably have too, glancing at, we've got, f of x, g of x, and finally h prime, h double prime going on. Okay, lots going on there. Example A, k of x equals sine x minus 3g of x plus x squared. And we want to find k prime of 1. I think our first game should be find the general derivative, meaning finding it at x. So I'm going to do a k prime of x. The derivative of k prime will be cosine of x minus 3g prime of x. Power rule next, 2x. We want to evaluate this at 1. So k prime of 1 would be cosine of 1. Okay, don't know what that is. That's not one of those values we memorized. Minus 3 times g prime of 1 plus a 2, because 2 times 1. Now, the only thing I need to do is go look up g prime of 1. G prime of 1 hits right here. I've got to create the derivative, so down 1 over 2 would make that a negative 1/2, wouldn't it? So I'm just going to leave cosine of 1 because I do not have that value memorized. And I would have 3 times negative 1/2 plus a 2, which would be cosine 1 plus 3/2 plus 2. So plus 3/2 plus 4 over 2. Looks like we're going to get 7/2, doesn't it? See how I converted 2 into 4/2? So final answer, cosine of 1 plus 7/4. K prime of 1. Oh, wow. This is going to take us some time getting through these, right? All right, next. M of x equals negative 4 natural log minus, and then it says find m prime. Let's go after the general derivative first. I'm going to replace this with x to the 1/2. Okay, so m prime of x. What's the rule for natural log? 1 over x. So I'm going to have negative 4 times 1 over x, which I could have written as negative 4 over x. I just didn't so that you could follow the work a little easier. Next, we're going to bring down the 1/2 and then reduce this by a power, right? Subtract 1 will give me negative 1/2. M prime of x. Here's my nice general derivative, negative 4 over x minus 1 over 2 square root of x, because that negative half bounces it to the bottom. Then we do m prime of 9. And that's going to be a negative 4 over 9. Everywhere we see an x, we're throwing in 9. Root 9 gets me a negative 4/9 minus 1 over 2 times 3 is 6. And you know what? I don't care if we put it together. Let's just leave our answer there. I'm too lazy to make, what, 36? They both go into 36? Oh, they both go into 18, wouldn't they? Can make it into 18ths if you wanted. All right, C. Okay, n prime of x, get our general derivative. Taking the derivative of h would make it h prime. Taking the derivative of g would make it g prime. Taking the derivative of 1 would make it 0. N prime of 4. So I'm just going to scratch that out. That's going to give me h prime of 4 minus g prime of 4 to the information up above. H prime of 4, oh, we get to use the table. H prime of 4 is a 1. Oops, not a negative 1. And then a g prime of 4, right there. That looks like a slope of 1, doesn't it? Minus 1. If you want, just put slope equals 1 along there, and we'll know where, slope of g of x, or g of 4, something like that. Oh, this turns out to be 0 then, doesn't it? N prime of 4 is 0. Continuing on, we got a few to go, don't we? All right, so D. Take the derivative, so we get p prime of x equals 0 minus e to the x, because the derivative of e to the x is e to the x, plus 2. I was at a single derivative. We go to a higher order derivative by doing double prime. And then they said evaluating this at 0. That's going to give me negative e to the 0 plus 2h double prime of 0 to the table. H double prime, right, lands us at 3. I get negative 1 plus 2 times 3, 6. That gets me a 5. P prime of 0 is 5. Why don't you pause and see if you can do E and F on your own? Okay, I did mine out, and hopefully you probably ran into a few little obstacles. There were some interesting ones here. Q prime, E of 3 turned out to be 0, because that was just a number, e raised to the third. E was our power, so we subtracted 1, and I just wrote it down then as x, e to the minus 1. E to the x was e to the x. And then I just put in evaluating at 4, so not too bad. The next one, a little bit more direct for r prime. I gave me f prime minus 2 sine of x, because the derivative of cosine is negative sine, so you can see my negative went out front. And then I rewrote x squared from the bottom as an x to the negative 2. It gave me a minus negative 2 x to the negative 3. Making it look pretty was my next line. I plugged in 3, and I had to go find then f prime of 3, which sits at a sharp corner, doesn't it? Oh, that's going to make that undefined. So, yeah, r prime of 3 turned out to be undefined. We have 3 problems to go. Hopefully I can keep this under 22 minutes or so. All right, s prime. Let's find it. We're going to do s prime of 8, but first we're going to get our general derivative. F prime of x plus h prime of 1. Ooh, h prime of 1. I think h of 1 is some number. That is 7. Let's update this with 7. They didn't fool us. The derivative of that's going to turn out to be 0. Minus 1 over x. We're too clever for them. S prime of x equals f prime of x minus 1 over x. Now, evaluating it at 8. That should be hopefully kind of easy, huh? F prime of 8 minus 1/8. F prime of 8, where does 8 sit? Right here. Can you read down to over to, oh, slope of 1. Slope equals negative 1, doesn't it, on that whole linear function? So I get negative 1 minus 1/8. Sounds like negative 9/8. Because this would have been 8/8 minus 1/8, getting us negative 9/8. S prime of 8. Notice how I script my work. The left side reads down and the right side reads down. It's very easy to follow. At least I hope you find it that way. Your work should be just as neat. There's no reason not to. W of x. Let's find our derivatives. Ooh, I first saw this down here. Let's write that as an x to the negative 1/2 as we prepare to take our derivative. W prime of x. Derivative of cosine is negative sine, so I'd have negative negative. That's going to be a positive 5 sine of x. The negative 1/2 comes down and multiplies by 3, so that's going to be 3/2. X to the negative 1/2 minus 1 will be a negative 3/2. Now, not much to clean up, but the one thing I see we could do is we can bring that negative exponent down to the bottom and have 2. Do you want to write it as a square root of x cubed? Sure, why not? Now we want to evaluate w prime of 4. 5 sine of 4, don't know that number, leave it. 3/2 square root 4, and then I think I'll cube, because I can take the square root a little bit faster in my head than cubing it and then taking the square root. So square root of 4 is 2, and so this would be 2 to the 3rd, wouldn't it? That's going to be 8. This will be an 8. And that'll be a 2 times 8, or 16, won't it? So final answer, 5 sine of 4 minus 3/16. Wonderful. And I don't know about you, but I just have to have my bottom line be completely reading a statement, an equation. Okay. Last problem. Woohoo! What do we got going? We got e to the x over 3 minus sine x and f of x. The only thing I would say about this is I prefer to see it as 1/3 e to the x, but that's just personal preference. Let's do our derivative. 1/3. Now the derivative of e to the x, it's e to the x. The derivative of sine is positive cosine, but we have that subtraction going on, so it stays. And then the last thing will be f prime of x. Take and evaluate it at 1. U prime of 1 equals 1/3 e minus cosine of 1 plus an f prime of 1. To the f prime of 1. Oh my goodness. Hits at a sharp point, doesn't it? This is undefined. So the whole thing ends up undefined. Watch those sharp points. All right, there we go. All done. You may start that worksheet.